Hello guys, it is Cleophas from on my Space Tutors. Today we will continue with our discussion on differentiation, and we will be looking at gradients of curves. So to do that, we are going to take examples. In our first example, you have been asked to find the gradient of y is equals to 3x cubic plus 2x squared plus 10 at a point 115. So we are going first of all to apply the power rule to find the gradient function dy dx. So this means that if you have your equation as shown here, then we have here the power is 3. You multiply by the coefficient before the independent variable to give you 9, and the power you reduce it by 1, so you have 9x squared. Here for 2, you multiply 2 by 2 to give you 4. The power, which is 2, reduce it by 1, you'll have x raised to power 1. So for 10, this is a constant. So if we differentiate a constant according to the power rule, it will give you a 0. Now that you already have your gradient function as described by this expression, to find dy dx at point 115, we go ahead and substitute x is equals to 1 in the corresponding gradient function. So this is the corresponding gradient function. So we will replace x with 1 as shown here. So next, what you are going to do is to evaluate the expression shown in red. 9 multiplied by 1 squared plus 4 multiplied by 1. So this is equivalent to 9 plus 4, and 9 plus 4 gives us 13 as indicated here. In our example 2, we are required to find the gradient of y is equals to 2x squared minus 2 at x is equals to 2. So we shall first of all apply the power rule so as to find the gradient function dy dx. So if we apply the power rule, it means you take the power 2 multiplied by the coefficient before the independent variable, which is 2. So if we take 2 multiplied by 2, we get 4, and the power we reduce it by 1, which means 2 minus 1, you get 1. So it will be x raised to power 1, which is simply equals to x. So in the end, we are going to have 4x. And then minus 2. Since 2 is a constant, if we differentiate it according to the power rule, it will give us a 0. So in the end, we shall end up with the gradient function dy dx is equals to 4x. Now that we have obtained our gradient function dy dx is equals to 4x, to find the gradient at a point x is equals to 2, we substitute x is equals to 2 in the corresponding gradient function that we obtained in the previous step. So we are going to do that. That is 4 multiplied by x, and you substitute x with 2. So you'll have 4 multiplied by 2 as shown. Next, we evaluate the expression. That is 4 multiplied by 2, and this will give us 8 as shown here. So the gradient at the point x is equals to 2 is equals to 8. In example 3, we are required to find dy dt at t is equals to 1, given that y is equals to 12t cubic plus t squared plus 10. So first of all, we shall apply the power rule to find dy dt. So that means that you take the power 3 multiplied by 12 to give you 36, and the power you reduce it by 1, that is 3 minus 1 gives you 2. And then for this second term, you have 2 multiplied by the coefficient here, which is 1. So 2 multiplied by 1 gives you 2, and then the power you reduce it by 1. So that is 2 minus 1 gives you 1. So this is the same as t raised to power 1, which is just t. And then we have the last term, which is a constant. If we differentiate a constant, it gives us a 0. So the end result is that dy dt is equals to 36t squared plus 2 t. To obtain the gradient at a point x is equals to 2, we are going to substitute t is equals to 1 in the corresponding gradient function. So this is the gradient function that we obtained in the previous step. So we are going to replace t with 1. So where t is, we put 1 as indicated here, 2 multiplied by 1. So after doing the substitution, the next step is to do simplification. So we shall evaluate this expression that is indicated in red. That is 36 multiplied by 1 squared plus 2 multiplied by 1. Indeed, 36 multiplied by 1 squared will give you 36, and 2 multiplied by 1 will give you 2. So basically, you have 36 plus 2, and 36 plus 2 will yield 38. So in our example 4, we are required to determine the point at which the gradient of the equation y is equals to t squared plus 3t plus 2 is equals to 12. So first, we are going to apply the power rule to obtain the gradient function dy dt. So if we apply the power rule here, it means that 2 we multiply by the coefficient here, which is 1, and that will give us 2. And the power, which is 2, we reduce it by 1, which means you'll end up with t raised to power 1. So at the end of the day, we shall have 2t. And then we have here 3t. So t is raised to power 1. So that 1 is multiplied by 3, which gives you 3. And then the power on t is 1. If you reduce it by 1, it will give you t raised to power 0. T raised to power 0 is just 1. So 3 multiplied by 1 gives you 3. If we differentiate the constant according to the power rule, it will give us 0. So this is our gradient function, which is 2t plus 3. According to the equation, we are required to determine the coordinates ty, whose gradient is equals to 12. So which means dy dt is equals to 12. We have already obtained that the gradient function dy dt is equals to 2t plus 3. So we are going to equate 2t plus 3 to be equals to 12, because 12 corresponds to the gradient at the unknown point ty. And then at this point, we are going to go ahead and solve for t, which will give us t as 4.5. Once we get 4.5, we need to obtain the corresponding y coordinate. To do that, we shall substitute t is equals to 4.5 into the equation of y, which provides that y is equals to t squared plus 3t plus 2. So we go ahead and replace t with 4.5. So where t is, we substitute 4.5. And if you evaluate this expression for y, we obtain that y is equals to 35.75. As a result, the required point ty has the coordinates 4.5 and that's 35.75.